Hoffaday students. For today, we're going to be going over quadratic functions and more specifically, how to graph them. Before we continue, there are some words that we should know. First of all, a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. This is also called standard form, where a is not equal to 0. When I say a is not equal to 0, it basically means that I need an x squared somewhere there in my function. A parabola is the u-shaped graph of a quadratic function. So this can either open up, as shown, or down. So it's a u-shaped graph. The vertex is the lowest point of the parabola that opens up. So we're going to draw here. The parabola would be right here. On a parabola that opens down, it's the highest point. So it's right there in the middle. The axis of symmetry is the vertical line that passes through the vertex. So when I say that something is symmetrical, it means it's the same on both sides. This means that if I were to fold this device in half right on that line, both sides of this function, this graph, would line up perfectly. The same goes for the line right here. So the distance from here to here is going to be exactly the same as the distance from here to here. So moving to the next slide, we're going to be able to see some of these things and identify them on a graph that's given. So on this page, we're given a graph of y equals x squared minus 2x minus 3. It is as shown. I'm able to identify my vertex right away. This is my vertex. It has the coordinates 1, -4. Again, the vertex is just a point on the line. We have an axis of symmetry right here through our vertex. It's a vertical line at x equals 1. So from here, from this graph, we're actually able to see very easily that this axis of symmetry divides this parabola completely in half. We can see it right here on these 2 points at the bottom. This first point is 1 unit away from the axis of symmetry. If I go count units to the other side, it's 1 unit also. Here we have 2 units. From the other side, it would be also 2 units. At the top, 1, 2, 3 units. 1, 2, 3 units. I can also see that this parabola opens up, smiley face. We'll be able to see in the next slide how to determine this if only given an equation. Now I'm going to be looking at if I was just given a quadratic function without a graph, am I able to tell if my graph opens up or down? So we will be able to do that. What we need to look at is a. So if our a is positive, our number before x squared is positive, then our graph will open up. It'll look like a u. If it's negative, it'll open down. A way I like to remember this is kind of silly, but it works. If a is positive, I think of a positive person. Positive people tend to be happy, right? So I actually draw a little smiley face right there. A is negative, he's sad, so maybe he has a little frowny face. Now we're going to go into how to find the vertex if given a quadratic function. So the formula for the coordinate of the vertex stays the same for all quadratic formulas in standard form. Okay, so they're going to follow this formula where x is equal to -b over 2a. This is very important. We're going to use this a lot. So find the vertex of the quadratic function algebraically. So looking at this one, what I need to identify right away, what are my a, b, and c, my coefficients. If there's no number in front of x squared, it's understood to have a coefficient of 1. So a is equal to 1. B is equal to -2. And c is equal to -3. Okay. Find the x coordinate using the formula, using x equals -b over 2a. I have x is equal to -2 over 2 times a, which is +1. So we have +2 over +2, which is 1. So the x value of my vertex is 1. The y value I'm going to find just by plugging in this x value into the original equation. Sorry, it's over here. Okay, so we have y is equal to x squared, we have 1 squared, minus 2 times 1, minus 3. Just subbed in our x value there. This is going to be equal to 1 squared is 1. Negative 2 times 1 is negative 2. Minus 3, working from left to right, 1 minus 2 is negative 1. Minus 3 is negative 4. So my y value is negative 4, x value is negative 1. This is true because right here my vertex is 1, negative 4. And my algebraic answer actually matches up with the graph. So now we're going to be going into how to graph a quadratic function. First of all, what I might want to do is identify my a, b, and c, which are the coefficients of x squared and x and the last number. So a is actually going to be 1, b is negative 2, and c is 1. Step 1, determine if it opens up or down. So for this one, I'm going to look at a. So the first number there. My a is positive. It's 1. It's positive. So this is a happy face. It's going to open up. Okay. The next step would be to find the vertex. So in order to find the vertex, I'm actually going to use the formula that was given in the previous slide where x equals to negative b over 2a. So if b is negative 2, my x is going to be equal to negative 2 over 2a, which is 2 times 1, which is equal to negative 2, which is 2 over 2, which is positive 1. So my x value for my vertex is positive 1. In order to find the y value, I'm just going to plug this into the original equation. Since y is equal to x squared minus 2x plus 1, my y is going to be equal to 1 squared minus 2 times 1 plus 1. 1 squared is just 1, so we have 1. 2 times 1 is negative 2. 1 minus 2 plus 1, working from left to right. 1 minus 2 is negative 1 plus 1 is 0. So my vertex is 1, 0. Step 3 is going to be make a table of values. So basically, once I plot my vertex at 1, 0 right here, I'm going to make a table of values to the left and right. So I want 5 points, including my vertex, on my graph. And I already know that each parabola has an axis of symmetry going through our vertex, so I can actually just draw one right here. This is going to be helpful when I'm graphing, so I'll know if I did it correctly. When making my XY table, I'm actually going to be using numbers from only one side of my axis of symmetry. So I might look at x's 2 and 3. So I'm going to make an XY table, XY, and I'm going to evaluate this at 2 and 3. I might want to do my work on the side so my table is easier to read. So if x is 2, y is, which is x squared minus 2x plus 1, is going to be equal to 2 squared minus 2 times 2 plus 1. So I'm just substituting in 2 for x into the original function. 2 squared is 4, so we have 4. 2 times 2 is also 4, plus 1. 4 minus 4 is 0, plus 1 is 1. So when x is 2, y is 1. When x is 3, I have y is equal to 3 squared minus 2 times 3 plus 1. 3 squared is 9 minus 6 plus 1. 9 minus 6 is 3 plus 1 is equal to 4. When x is 3, y is 4. So now we're just going to plot these 2 points, 2, 1, and 3, 4. Okay, so we have 3 points so far. So I'm actually just going to make these points a little bit more thick. Point right here, and right here. So since we have an axis of symmetry, and as we stated earlier, this means that if I were to fold it on this axis, it would be exactly the same on the other side. So the distance from here to here has to be the same on the other side. So I'm actually just going to go 1 unit again. So that's only 1 unit on the other side, and I'll have another point right there. Okay, the same goes for the point at the top. So starting at the point right here, I can count how many to the center, 1, 2 to my axis of symmetry, and count the same amount of units to the other side of the axis of symmetry. So 1, 2, I should have another point right there. Let me get there. So now I have 5 points. I can see what this graph is probably going to look like. I'll just trace it now. Okay, doesn't matter if you use one color or not. Okay. Awesome. It opens up. We have a vertex there. And then these are my 5 points. We're going to try another example now, doing the same thing. Now we're graphing y equals negative x squared plus 2x minus 3. So first thing I'm going to do again, identify my a, b, and c. A is now negative 1, b is positive 2, and c is negative 3. Okay. Determine if it opens up or down. Looking at our a, which is negative 1, it's negative. Frowny face, it'll open down. Find the vertex using our x equals negative b over 2a. We can see that x is going to be equal to negative 2 over 2 times a, which is negative 1. Negative 2 over negative 2, which is positive 1. In order to find the y value, I'm going to substitute it into the original function. Y is equal to negative 1 squared plus 2 times 1 minus 3. Remember PEMDAS, we're going to do this exponent first. 1 squared is 1, but I still have this negative in the front, so it's going to be negative 1 plus 2 minus 3. So negative 1 plus 2 is positive 1 minus 3 is negative 2. So I have a vertex at 1, negative 2. Let me just plot that right away. Positive 1, negative 2. So we have a point right here. There, that's our vertex. And since we have a vertex, we already know we can put in our axis of symmetry. So I have my axis of symmetry right here down the middle. Okay, next step, we're going to make a table of values. So we're going to do the same thing again, choose 2 values pretty close to our vertex. So if you want to go to the left, you can use that, but I don't really like using negative numbers, so I might just stick with 2 and 3. And I'll also switch to maybe a thinner pen because I know I'm going to have a bunch of work over here. So we'll make an XY table, XY. We're going to work with 2 and 3. So when x is 2, we have y is equal to negative 2 in parentheses, 2 squared, plus 2 times 2 minus 3. 2 squared is 4, but we have this negative in the front, negative 4 plus 4 minus 3. Negative 4 plus 4 is 0, minus 3 is negative 3. So a point here, 2, negative 3. When x is equal to 3, we'll evaluate y. Y is equal to negative 3 squared plus 2 times 3 minus 3. So y is equal to negative 9 plus 6 minus 3. Negative 9 plus 6 is negative 3 minus 3, which is negative 6. So I'm able to plot two more points right here where my first one is 2, -3. So we have x is 2, y is equal to -3. And x is 3, y is -6. And now all I need to do is reflect it to the other side of my axis and plot my two extra points and connect them. So counting from the point to the axis, I have 1, then I have 1 over there, so I have a point right here at x is 0. For the other one, I'll count again. 1, 2, 1, 2. So I'll have one more point right there. From there, all I'm going to do is graph it. This is how you graph quadratic equations. Obviously, the more practice problems we do, the easier it's going to be. So I really suggest trying this several times just to get a real feel for it. And then you'll start to remember the steps without having to go look at them.